So let's finish this first. Okay. So I'll again take the recap of the same example. Example number 2. You may see that there is an income data we have, and we have a number of employees, which is your frequency, and I need to draw the histogram for this data, and I have to interpret the result. So to draw the histogram, the initial condition was like your data should be continuous, right? That is the first condition. And second condition, you may have the width of that particular class interval will be the same. So if any of this condition will not satisfy, we have to be make uh, like if the width is not same, then we need to draw the histogram that income that is a class interval versus frequency density. But if it is discontinuous, you know how to make it continuous. One can able to make continuous. There is no problem. Okay. So satisfying both the condition, one can able to draw the histogram. So let us see how we can draw the histogram. So here is a 0 to 4.5. We have 3.333 means approximate. I may say 3 is this is 3. 3.33 means approximate here. Okay. So like this, and one can draw the vertical line till here. Right. So this is your first bar. Then 2.5 means approximate here, and the next interval is like this. So again, I can draw the bar. So you may go to the bar and you can draw the bar. Similarly, 4.5. Similarly, sorry, 2.5. Then 2.4. I'll take approximate here until 4. Now see, if you see the interval, sorry, this is I did set the width. So this is the 9 till 4.5 to 14.5. Okay, that means still here. So I need to just extend this line till here. I hope you are clear with this. So this is going to be this move till 14.5. This move till 14.5 like this. And the next win we have 14.5 to 19.5 means approximate 2.4. So I may take 2.4 will be approximate here, and again we need to draw the diagram for the same. Right, and then we have two. Now you can see the 2 ka length is 19.5 to 29.5. 19.5 to is this, and this will move from here to till here. So again we need to draw. This is in my system. I have to draw very carefully. Otherwise, my graph will not look like a graph. It will look like something else. So I have to just work a little bit slow, as it is not like a usual graph. Then 29.5 to continue 49.5. So it will move to 0.5. So my graph is like this. So this is basically called as histogram, and one may use it, and one can put the conclusion also. So what could be conclusion here? If anyone can put in the chat box, what could be the conclusion? So if you just draw the graph like this, taking as a midpoints, you just consider this midpoints roughly. So you may find this majority data is moving to the positive side. Means your data will be like positively skewed. The data is a positively skewed because as you like your age is increases, right? Number of employees increases, the income of that particular employees is also goes on increasing, right? So the data is again, so I can say again the same conclusion. Above graph depicts that. So from above graph we can conclude that data is positively skewed because more observation is right hand side. So one can conclude like this also. So this is the one way of conclusion. One can write this one. One can write this one. Both the meaning is same. You have to try to understand what it meaning. Okay, try to understand what it interpret. Okay, so data is positively skewed. Based on that, one can able to write the conclusion. So that is related to your histogram. So we did two problem. One will be where we are talking about the uh, where the class width is same, how we can draw it, what could be the conclusion. Another is when histogram, like when data is not continuous or width is not same, then how one can proceed with that. Okay, so though we have these only two things, so you may always uh, check that and you can able to do the things properly. Now next task which I was discussing, uh, that is called as stem and leaf diagram, which is very important. Okay, stem and leaf leaf diagram. So what this stem and leaf diagram says, the name itself you can understand. The stem and leaf means if you just see any tree, we have a stem, what do you call it? Stem, okay, and we have a leaf, right? In every tree we have a stem and leaf. So every stem contain more than one leaf, right? Even that, trees, if you see the have a seeds in the tree, every stem having some leaf, right? So you can consider any example like if I'm saying, suppose I consider this leaf. Okay, this is a stem. It contain one leaf. It may contain one more leaf. Okay, like that. So this is a stem, and this part is leaf. And you may understand here. You can able to count how many stem and how many leaves are there. If we have a tree, let's like a mango. So you can count mango. How many mangoes are there in trees, right? So even it is large, even it is large. But still you can able to count it. It is time consuming, but it is large. Okay, so what happened here, I am deciding about my stem and how many leaves are there in my stem. I need to understand, and based on that criteria I need to check again whether data will be positively skewed, negatively skewed, or it is right continuous. So the concepts of your I can say stem and leaf are same. The conclusion for stem and leaf and the conclusion for your normal distribution is same. There will be no change in the conclusion. Only thing is that we need to understand the concept. Okay, and their procedure is slightly different. So we can first see the one problem, and then we will go to the theory part, how this particular theory works. Okay, so let me take one example to make you understand how this particular graphs work. So let's take this example. So let me leave some space for the theory here so that you can go through that. I'll leave some space for the theory. Okay, later on we will write the theory of that. So we need to solve the first problem, how this particular problem works here. So let's take example number one. Okay, let us consider present present the following data. Present the present the following data in a stem and leaf display and interpretive result. Okay, so let's take the data. So I'll take very small data. Let me take for small data. For example, let's say 57, 94, 84, 63, 72, 51, 50, 48, 61, 71, 93, 82, 100, 89, 67, 78, 70. Suppose I have just considered these data. So how many observations we have? 2, 4, 6, 8, 10, 12, 14, 16, 17. Let's take only 17 data we have, right? So this is the data we have given, and I need to understand how to display the stem and leaf data. How to display stem and leaf data. Look at that screen. Huh? Look at that screen. Don't look here and there. Now, first we have to decide. First we have to decide what could be my stem. Okay. So the stem and leaf. Usually the stem will be the first number, second number, third number, like that. So if I'm saying, let's say solution, let's say the solution. Suppose I'm considering 57. So here my stem is 5. My stem is 5. Where my leaf is, where my leaf is 7. This is my leaf. Okay. If I consider any number, let's say 100. So here 100 means the 2 digits number. So 2 digits is stem and 1 is leaf. So it's based on the data. It based on the data. Suppose I have a 3 number 123, 125, right? 125, 129. So 12 will be my stem and 1, that is all my leaf. 1 all my leaf. Okay. So it is based on the problem whether it is 2 digits or 3 digits or it is 1 digit. But suppose I have only, let's say I have a 98. These 3 number I have, and I have here 98. So what could be stem in this situation? We need to add 0 here. Anyways, this is an outlier, doesn't affect in the problem. But remember, whenever we have a 3 digits, so first 2 digits will be stem, the last digits will be the stem. Sorry, first 2 digits will be stem and the last digits will be your leaf. So always try to understand first 2 digits or 3 digits or 1 digits will be the stem and remaining will be the leaf. Remaining will be the leaf part. So you always make sure that how you decide the stem and leaf, that is the important part. Okay? So how to solve the problem? Let's see that. Let's discuss that more about it. Okay. So what we need to do here, we need to understand first solution, how to do it. Okay. You draw one vertical line. Okay. You draw one vertical line like this. Okay. And if you see everywhere 5, 9, 8, 6, 7, 5. So if you see every first digits, what is the smallest digits? 4. And what is the largest digit? 10. So first you write down 4, 5. Even the 5 is not there. You can see 5 is not there. 5 is there. But if 5 is not there, no need to write. No need to write. 6 is there, yes, 6 is there. 7 is there, yes. 8 is there, yes. So when whatever number is there, you may write down that number. Suppose 9 number is not there, so no need to write. Like 9, is there 9? Yeah, 94 is there, for example. If the 90s numbers are like 9 के series में number नहीं है, then no need of writing the 9. So this left hand side of this is called stamp. So we have a stamp here, and in this case we have to write leaf. Understand how I'm writing. Okay. So first is 57. So in 5 we have 7. Next is 94. So 9 is there, 4 is there. 84, 4 is there. 8 के series में लिखने का. 63, write down 3 here. 72, write down 2 here. 51, so 5. Now you can see 7 are already written, write down 1 here. 50, write down 0 here. 48, write down 8 here. 61, So 6, 3 is there. Out beside your write 1. 71, write down 1 here. 93, so 3 write down here. 100, write down here. 100, 0. 89, 9 is there. 67, 67. 78, somewhere here. 79, somewhere here. I hope you understood. I hope you understood. Now, how? See, this is called unordered. This is called, sorry, I written, I think, let me do, just give me a sec, just give me a second. 80, 78 I have written, 79 I have written. So, this is called as unordered stem and leaf diagram. Unordered stem and leaf. But I have to make ordered. So what I have to do? Again I will prepare the same thing. Again I will prepare the same thing. Like this. Same data. Okay. Now see what I am writing. 4, 5, 6, 7, 8, 9, 10. First one 48. I will write 48 address. And you have to make it now order. Which is the minimum number here? 7. Sorry, 0. Write down 0, then 1, and then 7. Then in second case, we have 1, 3, 7. Next case, we have 1, 2, 8, 9. In third case, we have 4, 9. In next case, we have 3, 4. And the last case, we have a 0. We have a 0. And this is called as ordered stem and leaf diagram. Ordered stem and leaf diagram. And we have to make one note here. This 4/8 represents 48. And from above graph, from above graph, above graph, we can conclude that data is normal. I will say normally skewed, normally distributed. Data is normally distributed. So if you just rotate this graph, if you just draw like this, you may just draw like this. Sorry, ulta hoga thoda sa. You just simply draw like this. You may find this that the graph which is moving, it's moving approximated normal. Means it's look like a normal, right? Look like a normal. It is not moving positive side, not moving negative side. It's look like a normal. So that's why I may conclude that from above graph your data is normally distributed. So this is the technique. This is the technique which you have to do for stem and leaf diagram. Okay, and one may go with that and you can able to draw the diagram. Yeah, I think I forget to write 82. Okay, okay, okay. So you may introduce here 82, no problem. You can add here 82. No problem, you can add it here. So 82 I think missing, 82 is missing. So you can write 2 here and accordingly you can work. Okay. So you can just change this like you can change this is 2 and this is 9. This is 2, 4 and 9. This will be 2, 4, 9. Means approximately you will get the normal distribution. Yes, any other question? Let me know if you have any question. Yes, you can mute yourself and you can unmute yourself and you can ask if you have any question. Any more question? Have you understood the question? What is the need of it? See, as I mentioned, the need means importance, right? We are talking about the application. As we have seen for the data for the histogram, like the data for maybe for that graphs, the application of stem and leaf diagram and histogram is same. We need to understand whether the income of particular employees are increasing or decreasing, right? If you are working some of the companies and like let's say last 10 years, so is that my income is constant, or it is moving to the positive side, or it is moving to the negative side, etc., etc. Okay, so there is a required concepts of uh, shape of the distribution. You must identify the shape of the distribution. Okay, so the application of your stem and leaf. So here if you see the stem and leaf diagram, it's look like a normal, means it is equivalent to your histogram only. But for histogram we need have large data, but in stem and leaf diagram it is used for smaller data. So when we have a data and you want to check whether data will be normally or not, and data is small, then we go for always stem and leaf diagram when we have a small sample. When we have a small sample, and when we have a large sample, then I think you are knowing about large sample है तो हम लोग क्या बनाते हैं histogram. You know how to make class interval, you know how to decide class interval, everything we did it there, and based on that you can create a class interval and you can draw the histogram. So the important application of the stem and leaf diagram, it is used when we have a small data like less than 30, and when we have the more than 30 we draw the histogram, but make sure that data should be continuous. That is the important rule in the histogram. So you may try out one more example like how this stem and leaf diagram works. Okay, and let me know the second. Let me know if you have any query in this problem. First of all, this is the way we have to perform. डेटा आपको दिया है, स्टेम डिसाइड करो, लीफ डिसाइड करो, इसको बोलते हैं अनऑर्डर्ड स्टेम एंड लीफ, फिर उसको ऑर्डर में लिखो, दैट इज कॉल्ड ऑर्डर्ड स्टेम एंड लीफ, फिर यहाँ पे डिस्प्ले करो नोट 4/8. 4/8 का मतलब क्या होता है? इट इज 48, मतलब ये 48 रिप्रेजेंट्स करता है. एंड अबाउट डायग्राम्स क्या दिखाता है? About diagram what says? It shows whether data will be normally distributed or not. And see, there is a lot of applications. There are more applications of stem and leaf diagram. I have displayed only shape of the. I have just discussed about the shape of the distribution, but here is like you can able to interpret what could be the largest value in the data. What could be the largest value in the data? You can see 100. 100 is your largest data. What could be smallest data? 48. What could be the median? Like, are you getting my point? What could be the median? So median lies here. What could be the mean? Even mean you can find, but we should know how to interpret. What could be the quartile? What could be decile? All thing you can able to interpret from the data, from this graph. Everything. Means instead of looking this data, if I tell you have this data, find out median, it is difficult. But if you see this data and if I tell you find out median, within a minute you can able to find the median. Within a minute. Okay, so these are the few applications one can able to uh, use the application of stem and leaf, and you can able to get the mean and variance. Yes, any other question? So you may write it down. You may write it down the theory of this. Okay, so start write it down with me. Start write it down with me. Let me see if you have any query in chat box. So let's write down theory of this first. Then we'll move to the. So in the next class we'll do the practical based on this. Okay. So be present because I'm going to take attendance based on that. So what could be that? Let's start with theory. Uh, Write down. It is used for. It is used for group data. Write down with me. Huh? It is used for grouped data. Sorry, it is used for ungrouped data. So when we have ungrouped data or raw data, one may use this stem and leaf diagram. It is most useful uh, technique, most useful technique of exploratory. I mean, you can explore it. Exploratory data analysis. Data analysis. Steps. What are the steps? Let's see the step. Step number one. What is step number one? Divide the data or divide each value of the observation. Divide each value of observation into two parts. So if you just see the example how we did it, you may come across theory. We can able to write the theory by own. आप theory खुद से लिख सकते हैं. It is very simple. You need to understand how to frame the statement. हमने क्या किया? I have considered one number and I have divided the data into two parts. Can you see? वही लिख रहा है अभी. Divide each value of observation into two parts. One part, अभी एक पार्ट में क्या था मेरा? Stem था और एक पार्ट में मेरा क्या था? Leaf था. तो मुझे वही लिखना है. One part consists of one or more leading digits. अब ये थोड़ा सा समझने में आपको डिफिकल्ट पड़ेगा, बट ये थोड़ा सा आप बताता हूँ मैं क्या है इसके अंदर क्या होता है. लीडिंग डिजिट्स एज स्टेम, as stem, and the rest of the digits as leaf. For a three digit number, the first two digits form stem and last digit forms the leaf. क्या बोल रहे हैं यहाँ पे मैं? अगर मेरे पास दो डिजिट्स है, टू डिजिट्स मेरे पास है, so one can able to easy get what will be stem, what will be leaf. But I have suppose 3 digits. So first 2 digits will be your stem and the last digits will be the leaf. अभी यहाँ पे I was talking about something called leading digits. Leading digits क्या होता है? Suppose मेरे पास as I told you I have a number like this 90 24 26 29 and somewhere I have a number, let's say 09 or simply I have a 9 मेरे पास है. तो अगर ध्यान से देखोगे तो ये सब डिजिट्स कैसा है आपका 2 digits but this digit is single digit. So ये सिचुएशन में we have to lead 0. तो ये 0 10 मतलब 2 digits हो गया. तो start from 0 2. So 0 4 6 9 and sorry 0 2 4. So here we have a 0 के बदले 9 and then we have a 4 6 9. So why it is called leading 0? Because we are adding the 0 here. It is adjusted by 0 to make 2 digits. क्योंकि बाकी सब observation 2 digits में मेरे पास है, but यही एक single digits में है. So to add one more number, we have to try to make adjust with the leading digit, which is called 0. Okay, so just understand this concept. Sometimes you may across such an example where you are dealing with more than all observation in 2 digits, but some observation may be in the 1 digit, so we can adjust that statement. The stem and the stem values are listed out to the left of a vertical. As I mentioned, stem कहाँ लिखते हैं आप लेफ्ट ऑफ द वर्टिकल लाइन. अगर आपने थियरी अच्छे से, अगर आपने प्रॉब्लम अच्छे से सोचिए समझिए किया है, खुद से किया है तो समझ में आएगा. एंड लीफ वैल्यू corresponding corresponding to a stem value. So we need to add that corresponding stem value to the leaf value. So whatever the leaf value is there, we have to write it down corresponding to the stem value corresponding to the stem is written in a horizontal line to the right of the stem in the order, very important, in the order in which they are encountered in passing from one observation to the other. And what is third one? What we did? Finally, what I have to do? What we did last class. That means what we did in the last case. We arrange. Remember? We arrange it. All the leaves we can call it, because we have so many leaves now, in each row in ascending order. something spelling mistake, so you can be able to correct it later on. So this is the entire theory of your I can say stem and leaf diagram. And applications is same, right? And conclusion and application, conclusion, note. This is the note part. Conclusion and application is similar to histogram. Histogram. So whatever the application of your histogram is similar to your stem and leaf diagram. Only thing is that we use for for smaller data. Use for smaller data and ungrouped data. Obvious ungrouped data will be, I can say ungrouped data is not smaller, right? Smaller data does not mean that it is always ungrouped data, but generally we use for ungrouped data. Ungroup, G-R-O-U-P-E-D, group data. So when data is smaller or data is ungrouped, then we can go for stem and leaf. If the data is larger and data is grouped, we go for histogram. Okay. Make sure that this you don't forget. This you don't forget. Okay. So this is things you can always go with that. Yes. Any other question? Any other question? प्रैक्टिकल सबमिट हो जाता है तो मेल पर मैसेज आता है. यस आई थिंक प्रैक्टिकल करेक्ट करेक्ट. चंद्र कीतिका इज सेइंग करेक्ट. यदि प्रैक्टिकल सबमिट होता है तो आपको मेल आता है. देन व्हाई यू आर वरीड अबाउट यू हैव सबमिटेड और नॉट? आई डोंट नो. I don't have actually updated data. Okay, I don't have actually now right now I have updated